Today I have a 6-year-old Android phone, and right now it's running a full desktop Linux distribution. I can multitask, write code in Visual Studio Code, run a Python server, and even play AAA PC games. If I connect it to a monitor or a PC, I can use it on a bigger screen, just like a normal desktop. And the best part? Everything works without root. So, how is this possible? Let me walk you through it. Right now, you're looking at a full Linux desktop environment. This is XFCE running on top of Android using Termux and Termux X11. And this part is important. This is not emulation. Android already runs on a Linux kernel, so we're simply using that same kernel to run a desktop Linux userspace environment. That's why performance is much better than you would expect. Here's Firefox opening websites in full desktop mode. Audio works as well, which normally does not work in a default Termux setup. Since this is XFCE, we get the Thunar file manager. I can browse Linux directories normally, and I can also access Android storage from inside this environment, so it feels properly integrated. Now let's test something practical. This is Visual Studio Code running directly on the phone. I installed it using the Termux user repository, also known as TUR. I've installed Python as well, and here I'm running a small Flask server. And yes, I can access that server directly from the Android browser. That means this isn't just a demo environment, you can actually develop inside it. It comes with all the essential Linux tools you'd expect. You can install applications directly from the terminal using standard package commands. Since this runs inside Termux, we don't have Snap or Flatpak, but TUR gives us access to many desktop applications. For example, I can search for a package using pkg search, followed by the application name, and install it using pkg install followed by the name. That's how I installed GIMP, Blender, Visual Studio Code, and Python. The terminal behaves exactly like a regular Linux system. You can manage files, install dependencies, run servers, compile programs. Everything works as expected. Typing is also practical. In landscape mode, the on-screen keyboard may cover a large portion of the screen, but rotating the phone adjusts the layout automatically, making it much easier to work. If you connect a physical keyboard, it feels even closer to a real desktop experience. Now let's push it further. I first installed Wine to run Windows applications. It worked fine for lighter software, but when I tried installing heavier AAA games, it started crashing. So I switched to Winlator. Winlator is an Android application that allows you to run Windows x64 applications using Wine and translation layers. It creates a Linux-based container and runs Windows software inside it. And this is Deadpool running on my 6-year-old phone. Is it perfect? No. Is it playable? Yes. So this phone is now acting as a Linux workstation, a development machine, and even a Windows gaming device, all without root. But performance depends heavily on your processor. Now let's talk about installation. First, download 2 applications, Termux and Termux X11. Download both from F-Droid. Do not use the Play Store version. After installing them, there are 2 important things you must do before starting. First, open Termux and run the command termux-setup-storage. This will ask for storage permission. Allow it so the Linux environment can access your internal storage. Second, go to your phone's developer options and disable child process restrictions. Some devices limit background processes, and that can break the Linux session. Disabling this ensures everything runs properly. Now go back to Termux. First things first, we need to make sure everything is up to date. Go ahead and type apt update and upgrade, hit enter, and just let it do its thing. After that, install Git by typing apt install Git. Once Git is installed, next, head down to the description and click the link to my GitHub repo. Once you're there, copy the URL. Then go back to your terminal, type git clone, add a space, and paste the link. Press enter to clone the repository in Termux. After it finishes downloading, type ls to see the folder. Then move into the cloned directory using the change directory command. Inside that folder, you'll see the installation script. Before running it, make it executable by typing chmod+x, followed by the script name. Run it by typing // followed by the script name. Now the script gives us the option to choose our desktop environment. If you have a Snapdragon device, you're in a better position. Snapdragon processors use Adreno GPU, and there's an open-source driver called Turnip specifically built for Adreno. My installation script automatically detects Snapdragon devices and enables Turnip for hardware acceleration. If you're using MediaTek or Exynos, the setup will still work, but it will fall back to software rendering. In that case, it's better to use lighter desktop environments like XFCE or LXQT and avoid heavy 3D gaming. If your device supports hardware acceleration and has more than 8 GB of RAM, you can experiment with heavier desktop environments. If your device relies on software rendering, choose XFCE or LXQT for better stability. In my case, even though my phone supports hardware acceleration, I chose XFCE because it's an older device and XFCE was the most stable during testing. Installation takes around 7 to 8 GB of storage, so make sure you have enough space and keep your screen awake during the process. When the install finishes, it drops 2 scripts into your home folder, one to start it and one to stop it. Type CD to go home. From here, just type // then the start script, and hit enter to boot up Linux. Before starting, make sure Termux X11 is open in the background. Now open Termux X11. Within seconds, your full Linux desktop will appear, and there we go. We've successfully installed Linux on top of Android, and best of all, we've got full hardware acceleration. If you want Linux to start automatically every time you open Termux, you can add the start command inside your bashrc file. For gaming, start by installing Winlator from its official GitHub page. Once it's installed, open the app and create a new container. When it asks for the architecture, choose x64. Next, under Graphics, select Turnip if your device has an Adreno GPU. If not, choose VirGL instead. For the DirectX wrapper, select DXVK, and finally set the resolution to 1280 by 720. This usually gives you better and more stable performance on most phones. When the container opens, the D drive inside Winlator maps to your Android downloads folder. Place your game files there and install them normally. If your game is compressed, extract it using Android first instead of inside the container. It's much faster that way. So that's it. This is how I turned a normal Android phone into a functional desktop machine, capable of running Linux, handling real development work, and even playing Windows PC games. And the most impressive part is that this works without root, without modifying the system, and without flashing anything. It's simply using Android's Linux foundation the way it was meant to be used. Now, is it going to replace a high-end PC? No, but for development, experimentation, learning Linux, or even portable computing, this setup is surprisingly powerful. If you try this on your device, let me know your processor and how it performs. I'm especially curious how different chipsets handle hardware acceleration.